Hey, very good morning, students. Let us see the difference between Mealy machine and Moore machine. You should know that it's a very important question. This question is asked in part A as well as part B. Part A, 2 mark question, they will ask what is the difference between Mealy and Moore. You need to write two differences. In part B, by chance, if they ask, by chance, I will not say by chance, I've seen several question papers asking difference between Mealy and Moore in part B for 7 mark question, where you need to write a minimum of 7 points difference between Mealy and Moore. It's a very easy one. Let us start with it. So you should understand what is Moore machine. If you see this circuit of Moore machine, if you give an input to a circuit, a combinational circuit, you know what is combinational circuit. Your output depends upon the input. Okay, that output is stored in a flip flop. Whatever comes out of the flip flop is present state of that flip flop. If that present state is given again to a combination circuit, you can get an output. Now what I will write here, the output Y depends upon the present state of that flip flop. Such circuit is called Moore machine. Clear? Yes. Shall I repeat? If input is given to a combinational circuit, you know what is combinational circuit? The output of a circuit depends upon the input. Okay, that output of a combinational circuit is given to a flip flop, which is stored in a flip flop. So whatever comes out of the flip flop is the present state of that flip flop. The present state of the flip flop is given as the input to a combinational circuit, and that same present state is fed as a feedback to this input combinational circuit. Okay, now here can you see this present state is again given to one more combinational circuit. So you get an output. So what is the combinational circuit? The output depends upon the input. So what is the input which is fed to this combinational circuit? Present state of the flip-flop. So what is first point you need to write? The output Y depends upon what? Present state of the flip-flop. Present state of the machine. That is point 1. Now what is the next point you need to write is, this present state is not only given to the combinational circuit but is also fed back and given to the input of this, the first circuit. Okay, so what is that you write? After this present state, the next state of the flip-flop depends upon what? Present state. Can you see the next state of the flip-flop depends upon the input as well as the present state, which is fed as the feedback. So this is very important. The next state of this machine flip-flop depends on the present state as well as input. Clear? Yes, students, I repeat. What is Moore machine? The output depends upon the present state of the flip-flop. The next state of the Moore machine, the next state, what is next state? Next state of flip-flop. The next state of the Moore machine depends not only on the input but also on the present state. Done. Now let us see Mealy machine. In Mealy machine, can you see it is similar to Moore machine, but if you see here, the output of this Mealy machine not only depends upon the present state of the flip-flop but also on the input. So what is that you will write here? The output Y depends not only on the present state but also on the input. Clear? And what is the next state? You know the next state depends upon present state and input. Clear? So this is the difference between Moore and Mealy. In Moore, you will not get that input coming to combinational circuit. Whereas in Mealy, the input comes as a part of combinational circuit. That is what written in the first point. In Mealy, what is that? The output depends upon what? Not only on the present state but also on the input. The output depends on present state as well as input. What about Moore machine? The output depends only on the present state. The output depends only on the present input. Okay? Present state. If input changes, by chance, input changes, what happens? The output also changes. Can you see? If the input changes, output changes, because the output depends not only on the present state but also on the input. If input changes, output changes. Whereas if input changes, output does not change, because here the circuit input is not connected. So if input changes, output will not change. Now, Mealy always means less number of states, more means more number of states. Moore machine, more number of states, Mealy machine, less number of states. Since less number of states are required, can you see it needs, though less number of states are required, more hardware is required for implementing Mealy machine. Since more hardware is required, it is very difficult to design. This is direct linked point. More hardware requirement for circuit, since more hardware is required, it is very difficult to design. Here less hardware is required, easy to design. Next is, since more hardware required, very difficult to design, they react faster to the inputs. Okay, whenever the input changes, the output changes. They react fast to the inputs. Here they react slow to the inputs because it is not connected to the input, so they react slow to the inputs. This is asynchronous output generation. This is synchronous output generation. So output is placed on transitions. Always in Mealy, outputs are placed in the transition. From one state to other state, the output is placed in the transition. Here the output is placed on the states in the Moore machine. This is the difference between Mealy and Moore. So totally 8 points. If it is asked in 7-mark question, you can write 7 points. If it is asked in 2-mark question, you can write the 2 points. In 7-mark question, don't forget to draw this diagram. Okay, so that you get the full marks. Thank you.